So all the ports on the root bridge, the designated ports. Then on the opposite, we have the root ports, and then on the redundant link here, that is why we expect either the alternate or the blocked, and then again the designated port. So the the alternate port, it is in non-forwarding state. It can't forward anything. Eh? So still there, we have to look at the distance. Eh? We have to look at the distance from that port to reach the this and then this and then this one and then the other one. But most of the time, it's with the help of the switch roles. Because we have root bridge and then the backup root bridge. So the backup root bridge, it cannot have a blocked port. It can't have the blocked port. So when you look at this still, now this is the root bridge. You have to look at this. Which one has the least bridge ID? So the one that has least bridge ID, it's the backup. And the backup, you cannot say, let's assume that this is a backup. We can't say that this is alternate, that it's the one that is blocked. No, the blocked port, it has to be on the other switch, which is neither the root bridge or not the backup. Backup. So elect the alternate. I've explained that. So then we have elect root port from multiple equal cost paths. Yeah? That the cost path is the same. For example, let me just show you here the cost, the multiple equal cost. That I have a switch here, switch 1, and then I have another switch here. This is switch 2. The cost here is the same. The distance is the same. But this is port 1. This is port 2. This is port maybe what? This is port 20, and then this is port what? Maybe port 9. Eh? Okay, so when a switch has multiple equal cost paths to the root bridge, then the switch will determine the port using the following criteria: the lowest sender bridge ID, the lowest sender root ID. For example, if you are saying that this is the lowest sender bridge ID, let's assume that the priority here, it is less than 32. And then this one here, it is 32. This one here, it is less than 32, but this one here, it is 32. Okay? Then automatically, this one here, it's going to be the root bridge. Okay? The root bridge. So we expect this side to have the port that one port to be blocked, but all the ports this side, they want to be blocked. They'll be designated, and then this side we expect one root port. Okay, but now which formula are we going to use here? So if now this it can't, because now here we cannot tell which port to be. Then the lowest sender port priority, the lowest sender. You see here we are using the senders. Now we know the bridge priority, it's this. But which port are we going to block this side? And you tell? Okay. So here, the lowest sender priority, So on this, the lowest sender priority, you can see here, lowest sender. So here we have 1, and then we have 2. Which one is the lowest sender port priority? The lowest, it is 1. Okay, isn't it? Now, since this one here, it's the preferred one, then it means that this link, You see, it is connected to port 20. So it has to be in forwarding state here, and even this side be in forwarding state. Because at the sender, this is the lowest. It's the lowest. Now that this one here, it has the higher sender port priority, and then this side, when you look at it, it is the lowest port priority. But what determines it is the sender, which is this. It's the one that determines. Get it? It's like, let me just give you an example. This is port 1. Now that it's the lowest sender priority, it means that even if it connects it to any port, it has to, you get it? Because this is an ID, okay? But this side, the sender, it used to break a tie, this and this. Oh, this one here, the first one, port 1, it has to be active. But port 2, even if you're connected to port 1 this side, no, you have to be in an alternate state. Then we have the port, the priority. Oh, there is the priority, because now this one here, that one that I'm explaining, it's port ID, the port ID. But there is the priority. The priority, it's 128 by default. By default, it's 128. I will show it to you still, but I'll be a bit fast. So it's 128. So all these ports are 128. Yeah? 128. So if it's the same still, then we go for, we go for the port ID. The port ID, it's these ones here. This. So here we have an example here. Lowest sender, bridge priority, ID, lowest sender. Now with the lowest sender, when you look at this, we have this switch here, switch 2. See that this link here to this, and then this one here, they are, by looking, the cost is equal. So here we have from this to this we have 38. Even here we have 38. So you cannot base on this. You can't base on this. But remember, this is the root bridge. Now, if it's the root bridge, then we have this, and then this. Now, on this one here, the 2, you see, these 2, there must be a backup. Okay? There must be a backup. So if then in case there is let's assume that the backup is this. If it's the backup, then it has to make sure that still it has the link connected to other switch without being blocked. Because it's a backup, you have access to the other switch. But if this is not the backup, then its link here, we expect that on this, that is why we're supposed to have the alternate link. Because that switch, it's not, doesn't hold any switch role on this. Now, on top of that, when you look at this, that this is the distance, and then this distance, and then the priority, the sender priority, it's the same. Here, if you go through this, and then even from this this side, they're the same. On this, and then on this, then automatically we are going to look at the ports. The ports. So on this one here, and then this. Which one? Now here we have the 1, and then here we have a 2. So a 2, it has to be blocked. But nothing from switch 2, if I use switch 2 this, or if I use this one here, then automatically the 1 here, a 2, it is higher than this. So this lowest, the sender, the lowest sender's port ID, which is this, it's the one to be considered, and then this, it's going to be blocked. Then this is what I explained automatically the other side, where I drew two switches with this. Right? So this is the 1, but it's connected to 6. This is the 2, it's connected to 5. So it's not this to decide, it's this side to decide. Since this is a 1, then whichever port that is connected to, it's a 6. It has to be in forwarding and then forwarding this. So this is the 2, it's in forwarding, but it's not preferred on this switch. So meaning that this side, it has to be blocked. So when you look at the port priority, it's 128, 128. Still it can't cut, it cannot break a tie. So it's the port ID to do to break a tie. Okay, so it is there, as you can see now, the port that is blocked. 3 timers. So in that process of converging and blah blah, it's not just immediately. So the moment you change this, you lower this priority, then immediately it goes to, it changes to that state or in that row. There, the timers. So we have a low timer, is the interval between BPDUs. BPDUs. So the default is 2, and it can be set or modified between 1 and 10. So we have forwarding delay timer, the error timer every time. Attention guys, attention, that the default is 2. Every after 2 seconds, it sends error message, the BPDU message. It exchanges that message with the neighboring switch, but it can be edited to 1 to 10. Then forwarding delay. The forwarding delay is the timer that is spent in the listening and learning. Listening and learning. So it has to listen and then start learning. So the time that it has to spend in that, the time interval, it's the default, it's 15. It's 15 seconds, but it can be modified between 4 to 30 seconds. And at that time it is needed. You cannot actually maybe alter it to be below the stated one, maybe like 3. Because if you state 3, then automatically it's going to create loops. It has to, in that time, to negotiate. It's like, if someone is entering here, are you going to allow whoever wants to enter, but you can be on the door, who are you, which course, so that if maybe the course you're doing programming, you're not mistaken and you find yourself in this. At that time, it has to be there, checking. Who are you? Yes. Did you pay? Yes. Which you paid for which course? Because you paid, maybe you paid for programming, not CCNA. Oh, if it's programming, go on the other side. Even the other person will do the same at the entrance in that time. So it is needed time. It's not an accident time. Then we have maximum edge time. The maximum edge early, pay attention. The maximum edge time timer, the maximum length of time that switch waits before attempting to change STP topology. Yes, there is a change on the network, but there is the time that it has to wait. You get it? So in case you want some from here, maximum edge time. That even if the other switch, the root bridge switch is down, the other switch, it's not going to come on board there and there. There is that time it has to wait and confirm that this is down, and then it takes over. The states. The states, there are 5, but the active ones, there are 4. We have blocking, listening, learning, and then forwarding. So the blocking, no BPDU received, the maximum edge is 20. Listening, forwarding delay, it is the listening, forwarding delay. It has to wait to forward 15 minutes. Forwarding delay, it's still the same in line learning. Still, it has to wait for it to change, to change from this to the other state. It has to wait those 15 minutes. And then we have the non-operation state, which is disabled. Once the port is disabled, that is it. it's you to go back, and it will not change automatically. It's you to go back and activate it. So the state and what those states can do. So the states, we have 5. When it comes to the messages, when it's blocked, it receives only. Remember the other scenario, that what you can do is just wash the car, open, blah, blah, that is it. BPD, it receives, but it cannot even, that port, it cannot populate the MAC address table. The MAC address table. So still it can't forward the frames. In listening, it receives and then sends. So in blocking, it keeps on receiving. Okay, receiving. It's like learning. It receives and then sends, and then it starts updating. That is learning. It starts learning the MAC address, but still it will not forward the BPDUs, the frames. Okay, the frames. The frames are just the message. Then when it comes to forwarding, now it updates the MAC address table. At the same time, it starts sending the packets, the frames from the source to destination. When it comes to disabled, that one, the link is down. It won't do anything. It won't do anything. So we have Paviran spanning tree. Paviran spanning tree. Now this one here, it deals with these different VLANs, that you have VLAN 10, VLAN 20. So you can try to distribute that VLAN 20 on switch 1, it's a root bridge. But VLAN 20 on switch 2, it is okay, VLAN 20, the other on switch 2, it is a backup. So, sorry, you have VLAN 10 as root bridge switch 1. But when it comes to switch 2, VLAN 10, it is not a backup. Not a backup? No. Switch 2, sorry, 10 on switch 1 in this scenario. That we have this switch, we have 10 and then 20. Okay? We have this other switch, we have 10 still, then this 20. But it's connected to another switch. We have 10, 20. Okay? And this. Like this. That here 10, it is the root bridge. Then when it comes to this one here, 10 is the backup root bridge. You see that? But a 20 here is the root bridge. See that? And then this side, a 20 is the backup root bridge. I think that in scenarios, yes, we on the same page. All we need to do is just to do it practically, so that you see it. That it will be you're the same. You're learned here. You're the trainer. But immediately, once you go in another group, no, here you are a trainee. Or there you are a trainee. Altogether. So in this scenario, since this is VLAN 10 is the root bridge on this, VLAN 10 root bridge. VLAN 10 here is the backup. Okay? VLAN 20 is the root bridge. VLAN 20 is the backup. Think that when it comes to the port role, this here, which is port 1, under VLAN 10, it is going to serve as designated port. But under VLAN 20, it's going to be root. So on the switch, they are grouped very well. You will see VLAN 10, the port, because the port is not going to change. Port 1, it is root port. Under VLAN 20, port 1, it is designated. The evolution of STP, we need just to look at, because there are multiple types or the variety of STP. So we have a spanning tree protocol, the flash, which is this. Then we have per VLAN STP, per VLAN STP. So when you look at these are STP, and then this Cisco enhancement, it's Cisco proprietary. Then we have this one here, which is an updated version of STP standard. Then we have rapid spanning tree. Then we have rapid per. This is with just VLAN 1. VLAN 1. But the moment you have VLAN 10, blah, blah, and then you start distributing VLAN 10 on this root bridge, VLAN, blah, this, there you're dealing with per VLAN or rapid. The difference between these two, that STP and then rapid, is that the states are reduced from 5 to 3. This one here, it has 5, then this it has 3. Okay, it has 3. So the RSTP concept, it's all about that the states, they are reduced and it's fast in convergence. You will see that, that the state, the convergence, it is very fast. It happens in second, because that the delay is needed. Okay, the delay is needed, but the sum steps are extracted. So here there are states where we have the rapid, and then we have flat STP and then rapid. So when you look at this disabled blocked listening, so the 3 here are blocked to discarding. Discarding. Then learning, it stays, and then forwarding. So all this, the blocked, from blocked, now to negotiate from blocked, learning, those ones out, these are out. We have the discarding. So when it comes to this, look at this, the port role, see, that under this discarding, okay, with the STP, we have root port, we have designated, and then blocked port, or what you call the alternate. Alternate. But when it comes to rapid, now this, the blocked, it is divided into 2. So we have the blocked or alternate. Blocked or alternate. So in scenarios where you have this, at the alternate, it works on a hub. It's a hub. So it will be treated as the alternate. Sorry, not the alternate, but the backup. The backup. So here we are with our port roles. This is our root bridge, as you can see. So these are designated port. Then the opposite, root port. And then now, here, as you can see, this is a redundant link. See this. So we expect an alternate port, which is this. The alternate port. But when it comes to the scenario where we have a hub, as you can see, we have a hub here, that this other link, it's going to be treated as backup port. Backup port, not an alternate port, neither blocked port. So it's this that is blocked, because you are on this. But this, as you can see, it's just this and then this. But when it comes to this alternate, it's an alternate path among these three, the three here. But this one here, backup, it's just a backup for this device only here. So we have port first and then BPDU guard. So the BPDU guard still I will not go through this what you have, but let's assume we have our switch here and then this. You have end device and this. So between these two switches, they have to keep on exchanging them. So the BPDU, bridge protocol data units, this messages to keep updating each other in that process of STP. This. Now, if someone comes and disconnects, like what you always do here, disconnects this cable and connects it to another switch, then automatically this switch will be able to send the BPDU to this, and this switch will be able to reply. Now that one, it jeopardizes the security on the system, on the network. You get it? Meaning that you can add, you can put, or you can add a switch on the network, and it's going to work. Right? You get it? So to restrict that,